people see there's some sort of like wizard in a purple hat in the trees up there? So that is me or you, a data scientist, trying to build models and deal with organic things arising constantly and streaming data and these types of things. But there's a huge amount of infrastructure that goes into building the types of systems that allow us to do that up the top. So we have a platform engineer down the bottom setting up all the infrastructure. And the second half of this talk will be one such incredible platform engineer, Sam from Carsales, the company formerly known as carsales.com.au, talking about what they get up to there and how they use Metaflow for these purposes. But before we get into all of those details, I wanted to kind of reason through why we even need to talk about infrastructure as a different concern in data science and machine learning and AI as opposed to traditional software. So just to get a sense of the room, who works as a data scientist? Great. Or data analyst or machine learning engineer? Anybody working on infrastructural stuff? Okay, really nice. So we've got a variety of people in the room here. So I think a lot of what I'm going to say you may have a sense of, but I want to kind of formalize it in a particular way. In that, what do we want from traditional software is a question I want to pose, and then think about how we can achieve that using software that's powered by data and machine learning and AI, right? So if I were to rank order like the most important things that we need in software, two of the most important are we want it to run reliably without human supervision. So when I go home at night, or I work at home now, so when I close my laptop at the end of the day, I want to make sure that the software is running. On top of that, I want it to be running correctly. I want it to give correct results. So these are two incredibly important things. And these remain when we think about machine learning powered software. But we have a whole bunch of different components in the system now, right? We have data introduced to the system. And this is data that's updating and changing and being added at regular cadences, right? We have some machine learning model or statistical inference model, whatever it may be, in the middle, whereas we didn't necessarily have that with previous traditional software, right? These systems are for the most part non-deterministic as well. So we have that changing. So we have the kind of entropy of the real world introduced into your software system via data and machine learning models. On top of that, we don't only have software engineers or platform engineers anymore, we have this new role which emerged a bit over a decade ago, 15 years now, we're still kind of figuring out, called a data scientist whose skill set is not necessarily the skill set of traditional software engineers, right? But they bring a lot of different skills to the table that are deeply important for these roles, which are rapidly prototyping, experimentation, exploration of data, building models, all of these. But these things aren't necessarily immediately compatible with inserting into traditional software systems, right? So what they actually now have to do, what we have to do, is interact with models and data and code. And these are kind of the building blocks of what we're working with, right? But there are more layers as well to the stack. And so I want to build up a picture of what the stack really looks like for machine learning. So for models to interact with data and to build models from data, you need that to happen somewhere. So you need some computation, like a laptop, right? Increasingly, we require more scalable forms of compute, such as cloud infrastructure, Kubernetes clusters, with the advent of generative AI, which currently are incredibly compute intensive for the most part. Maybe you want more compute. I think one of the most exciting things that I think is going to happen this year in generative AI is the release of a lot of different models that don't require significant compute. I don't know if you saw, but Mistral's new Mixtral model from last year, you can actually run on your iPhone now, which is absolutely incredible. So we're going to see a lot more of that. But compute is still an incredibly important part of the story. In terms of writing models using code, right? Maybe you've done this in a notebook. You can do, scikit-learn, fit and predict. Then you start doing some feature engineering. Then you're doing cross-validation and then you're parallelizing a bunch of stuff. Then you're building some different models to get different results, but using the same data set and doing a join. And suddenly you've got a machine learning pipeline with, 10 steps, maybe 100 steps, I don't know. At this point, when your models start getting more and more complicated, you want to start orchestrating your code. So kind of thinking of it as graphs, essentially, where you start with a step And in the end, if you know a bit about data pipelines, maybe you've heard the term DAG or directed acyclic graph, doesn't really matter. That's a technical term to mean a graph with some properties that respect this data flow paradigm. But in the end, you're going to start wanting to use orchestration tools and have an orchestration layer. Now, on top of that, we can't forget that these models are being built iteratively by humans like us, right? And, whoa, mouse fail, right? And so we're rapidly prototyping these models. And so we're going to have lots of different versions of models. So we've all worked probably with GitHub and forms of version control with code. But now when rapidly iterating on models, we actually want to start versioning our models and perhaps even versioning our data sets. Let's say a model gives a really bad prediction, that's a failure mode for a particular team in a company, right? And they want to then root cause what happened. So you want to then retrieve which model, which run of that model, and what data produced the model that failed, right? So you want to be able to version all these different moving parts of your system. So we require a versioning story as well. Now on top of that, all of this would be moot if we weren't able to deploy models, okay? So we need to think about deployment as a key part of this infrastructure stack. Common misconception that deployment means some API, some like endpoint REST API or whatever it may be. Most deployment stories I've ever seen in industry are actually some form of batch inference where people are, for example, running a model, doing predictions, storing them to a data warehouse or somewhere on S3 that's then retrievable to build dashboards or whatever it may be. Deploying a model could also be sending out a weekly email to your marketing or customer success team with their key metrics and these types of things. Another deployment story, which actually is one of the most impactful, I think, is generating a slide deck for an executive to consume. And then probably make the decision they would have made anyway without the slide deck. No, that's just a joke. But I do think multi-million-dollar decisions are made from machine learning models that are deployed via human consumable slide decks. So I don't want us only to think that the only things happening are in feeds and recommendation systems and all of these, which are very important aspects of the story, right? So what we have in this machine learning infrastructure stack. We start with data, then we need some compute to build the models. We need the orchestration layer, versioning, deployment, and then modeling, using all the packages you love on top, such as scikit-learn, PyTorch, XGBoost, right? Now, data scientists really want to focus on the top, but there's an increasing amount of infrastructure required for the bottom. And just to allay any concerns, it looks like I'm saying data scientists don't care about data. Now that's clearly not true. They care about the data that they want in order to model the phenomena that they're interested in modeling. What isn't necessarily their concern is how it's engineered, the ETL pipelines that go into getting the data into, and where it is. Is it in Snowflake or BigQuery? Are they using BigQuery or is it in Parquet shards on S3? These, a lot of data scientists want to abstract over and have the data to work with as quickly as possible. I'm going to hand over to Sam in a minute, but I do want to just give a sense, because we are a technical audience, of how we think about this in code. So this is some example Metaflow code, which essentially you can see it's object-oriented programming. I'm defining a subclass of something called flow spec here, which allows me to design some sort of flow, right? And I have two steps in it, a start step, where I'm instantiating a variable self.x, instance variable equal to 1, then an end step where I'm just adding 1 to it. I'm incrementing it, right? So this is a toy example. You'd be doing all types of modeling and feature engineering and that type of stuff in a flow such as this. But already this demonstrates a lot of the aspects of the layers that I just talked about in the infrastructure stack. So for example, who's ever had dependency management issues in Python? Pretty sure people on the street just raised their hand as well. So on the modeling side, there are Metaflow decorators such as at Condabase. There's also at pip, which allow you to specify at an entire flow level what packages you want installed. Now you can also do this at a step level, which is very important because let's say you only require PyTorch for a particular step. You don't necessarily want to import that for your entire image, right? In every step along the way. In terms of deploying, you can use an at schedule decorator, which will deploy this daily at a time of your choosing. I mean, there's a default argument here, but this will run daily. Of course, this will run daily if someone such as Sam has set up a platform which allows you to interact with these types of schedulers. So there is infrastructural setup that is required for all of this. Just as, the versioning story, everything that you assign as an instance variable is actually stored in a metadata store, in a blob, on AWS, wherever else you want to put it, because there's multi-cloud support. But essentially, it will store all the information that you want it to up wherever you want it to be, including models, code, and data. The orchestration story is told by this entire flow. In terms of compute, once a Kubernetes cluster is set up, if you have a step which requires significant compute, you can merely use an @Kubernetes decorator, for example, which then sends this particular step up to the cloud, and you specify, whatever memory you need as long as it's been provisioned. And then on the data side of the story, it's a similar story. You work with data within these flows, and you're able to access data from wherever you want to access it. Just as you can use any packages, open source packages you want, and otherwise you're able to interact with data across a variety of different services. Now, finally, before handing over to Sam, I'd have to fire myself if I didn't say a bit about how generative, it is early 2024, so I've got to say LLMs at one point. Okay, but no, I really do mean this. We really need to think through how generative AI changes these types of workflows, right? So I've got a schematic of one way you can think about how you incorporate generative AI into your software, right? So you may be using an open source foundation model, such as one from Mistral or one from the Llama family, Llama 2, for example. You also may be using some sort of vendor API that you see at the bottom. And you'll see that we have this governance boundary here where we're in control of everything in the middle there, but we're not necessarily in control of an open source foundation model or an AI vendor API, okay? And there are very different concerns with each of these, right? And you may have concerns about using open source foundation models. Using AI vendor APIs, costs can blow out pretty significantly, but with foundation models, you need to provision resources yourself or use a cloud vendor as well. With AI vendor APIs, if you're using a product that's built by a company that has like this weird non-profit structure with some profit motive attached that's sponsored by one of the biggest incumbent tech companies in the world, that has like all these ownership, like boards firing chairmen, the CEOs and that type of stuff, maybe that's a concern. Maybe you want to start thinking about, working with other vendors. Like, I'm not saying you would, but these are legitimate concerns. And I do use OpenAI a lot and ChatGPT a lot. But these are all legitimate concerns. But what are we doing with these is the real question. And they can provide a huge amount of value so an open source foundation model, we can fine-tune it, for example, in order to make it more relevant to our specific use case. And we can serve responses from the fine-tune model to a customer service chatbot. We can then build embeddings to make personalized recommendations that are fed into a product. But we're also generating images for that product, storing them in cloud storage, which are then accessible. And a lot of these things are coming from a data warehouse as well. So this is just to give a brief sense of how we can start thinking about incorporating generative AI into.
So what's the use case what you are building on this journey?
So this is actually a very general example. So I've just said here it's a product, right? So it could be an e-commerce website, right? Where, for example, let's say that okay, let me think. So I have you come to my e-commerce website, and I ask you a few things to solve the cold start problem, and then I'm suddenly making recommendations to you of things you may want, right? And in that sense, I would use an open source foundation model, fine-tune it on my own company's e-commerce data, and then serve predictions or recommendations to you as you come in and tell me things. In terms of having an AI vendor API that generates images. Maybe it's a product where you want to build out your living room and you want a red couch. And then, so we have a generic living room there, and you say, I want a red couch with so-and-so coffee table, so-and-so lamp. Then I would use an AI vendor API to generate images based on exactly what you've wanted there. So those are a couple of, I mean, it's extensible across the entire space. I probably should have talked about cars, actually, because all of these, no, you've got a car set and all of these types of things. But this isn't going to happen tomorrow, right? This is something, what I've just described sounds intuitive and relatively straightforward, but to build something that actually works like that, maybe 5 years, we're going to start seeing a lot of that stuff. I mean, still, you've got IKEA's website, and I presume like you put something in and it's still interacting with a SQL database or something like that, right? I mean, so I just want to say a couple of things about how the stack changes and doesn't change. The ingredients of the stack do not change here. Things may have slightly different weights, but data is still a key concern, right? And perhaps increasingly important as we're generating a lot more data with generative AI, right? The output of every model is, I think one of the scariest things is actually, with the internet, distribution of content became essentially free. Now the generation of content is essentially free, and I think that's something which is going to be, I mean, when the internet is mostly full of AI-generated content, it's going to be a day. Go off the grid completely. I think compute, as I said, is actually even more important now, although we're going to see that change. I think we are seeing it change. Of course, the companies and vendors and products that have most mind share will always be telling us that we need more and more compute, but we need to figure out what our actual business and personal needs are and figure out what type of compute we really need. Orchestration, still an incredibly important concern. Versioning, even more so now. When we're generating a lot of natural language data, we've got a lot more that we need to version. And I think this is an evolving story that we're not even sure of how versioning should be working in this space. And so that's very, very interesting. And once again, the deployment story. We want to make sure these models are live, these products are live, and that when we all close our laptops at the end of the day, they're still delivering the business value that they are when we're at the computer. So, without further ado, I'd like to introduce Sam, who's going to talk about all of these things, but with respect to the actual, I mean, this is all, by way of introduction, all the actual business value that they're able to deliver at Carsales. So, thanks.
Thanks, Hugo. From Carsales, I have some of my colleagues here, Gavin and Fauzi. So, I'm not an expert at everything, so if I can't answer some of the question. Anyway, Carsales, for those of you who are not familiar with, or people in the internet, Carsales is the #1 online marketplace for anything with wheels. You're trying to sell them, cars, bike models, not airplanes. So our aim is to make a buying and selling experience, a good experience for users. So I'll talk deeper into this because this is one of the key important business points. And of course, we work with OEMs, B2B businesses, trying to create a one environment place for them to do what I mentioned before, buy and sell cars. So let's move on here. So how do we use AI at Carsales? Some of you have asked me that question, oh, what do you do? Well, how do you use AI in Carsales? So I'll try my best to reveal to you some of the things that we are using. So bear with me here. So we categorize it in 3 pillars. I'll call it 3 pillars. One of them is we use AI to improve consumer experience. Hint, hint, that was something to serve our business case I mentioned earlier. Second one is we use AI to enhance trust and safety. Don't worry, I'll go deeper into it. And then the third one will be optimizing engineering and processes. So these are the 3 pillars. We just categorize them the way how we use AI in Carsales. So the first one, improving consumer service. There's a bunch of words there. Essentially, we try to leverage different AI technology to, at the end of the day, create something that you feel you want to use our website in a much better way. Again, there'll be a use case product. deep dive later. And then the second part, enhance trust and safety. When it comes to car sales, when we sell cars, there are certain things we are concerned about, particular to in car sales space, whereby is it the correct car you're selling? Are we representing correctly? So correct information. So we want to create, using AI, I'll talk about that more again, how we can ensure that the advertisement you place there is safe, is correct. And of course, internally, there are some validation process that we use AI to make sure that what people are selling is actually true. And then the last part here, optimizing engineering processes. We use something called, we try to use more and more AI. So Copilot, some of you may have started using it. So we are embedding that a lot to help us leverage AI in our company itself. So moving on to our first use case. Some of you may have heard of this. This product came out 2017, 2018-ish. There was a talk given by our founding member of our team. He's now the GM of AI in car sales. So Cyclops is an image recognition technology. It has two capabilities. One of them, we call it Cyclops Angle and Cyclops Kazam. Kazam came from the inspiration from Shazam. So when you can detect a song, you can detect the car through images. So you can see, I'm not sure we can see, but you can see different angles of part of the cars. So very early on, before this AI tech exists, we have users internally, like photographers. They have to go and take photos of cars, and then they have to come back and label it manually. This is the wheel. This is the steering. With this, we literally almost take the job out of them, and they can concentrate on something else. So who likes labeling? Who do data? So this plays a green tick in our box. Not only that, we advertisement that comes to our website, like users posted advertisement on website, I'm going to sell this car. We have some sort of approval process. It used to be a very manual process whereby a person will be sitting down, advertisement comes to a screen and say, okay, is this person saying what's correct? I have to read through, make sure this is good. This is what they say. Nissan is a Nissan. Nissan is not a Toyota. That type of manual approach. So using this technology combination with other services internally, we managed to reduce those kind of headache, trying to figure out eyeball, is this correct? So this automates a lot of that away. So that's one of the use case using AI tech. The other one, recommendation system. Do you like to be recommended with food that you like to eat? Answer is generally yes. Give me something new. Give me something new, but I'm not telling you what I like. I want you to tell me what I like. So we have something called MyFeed. MyFeed is just the name of the product. Basically, recommends cars for you. So there should be a red box here, but we can't see that. Some of you who have used our website or from an iOS app, if you have, this is based on your browsing history. It needs to find a way to figure out, okay, you have been through this. Okay, we're going to recommend you this. YouTube has done that. A lot of other platforms has done that. So we have something similar like that for cars. Moving on. So using, thanks to orchestration tool like Metaflow, this is one of the architecture we use for just taking MyFeed as an example. MyFeed, we actually use a few different types of data. One is interaction data that figure out what have you interact with in the website. So it comes from Google. Of course, we use some of the services from Google, and in combination with internally, we have inventory data about cars. So combination of a few of that, we collate it into, I'm simplifying it in a data hub, and from there, extract whatever data set we need. There's a lot of work to be done in data preparation. Go ahead with model training, and because the flexibility of Metaflow as an orchestrator, if you think in that sense. We can use other types of services. So we leverage Amazon SageMaker as a place to host our model. So who knows training is cheap? For those of you who have done model training, depending how heavy it is, model training can be cheap or can be very expensive. So the approach we took is we have a inventory, register all the models. So if our business have a different level of requirement, but similar type of model, but flavored differently in the business layer, we don't need to train it anymore. We have it, pick it up, reuse it somewhere else. So that helps us reduce the cost of needing to train something many times just for different kind of business output. So that's one of the architectural approach. Now let me talk about the Carsales secret sauce. No, it's not really. Technology that we use behind the scene. So it's no longer secret now. We use AWS and Metaflow. In combination, I mentioned earlier, some data comes from Google and Amazon combination. Development, deployment is Metaflow itself, and monitoring, Grafana and Slack. That's how we monitor whether our model has been deployed properly or has not been deployed, and so on and so forth. Back to this, why Metaflow? When Hugo approached me to talk about this, I have a hard think about why we use Metaflow. And it was actually what I would call a journey. Metaflow wasn't something that we chose early on. And in order for me to tell you why Metaflow, I have to give you a bit of context. Anyone seen this before? Yeah? Yes? So for those of you who haven't seen this before, this is sort of what it requires for you to create a product from end to end. Like if somebody has an idea, business has okay, I need this, and you must have some AI technology to, it has happened and is delivering now. This is one of the representation or many versions of it. Those are what I'm trying to illustrate is there's a lot of process involved in getting a AI kind of tech out there, ready to be used from inception. And there are different, like Hugo mentioned, there are different roles involved. There are engineers, software engineers, there's new upcoming data scientists, machine learning operations, all sort of processes that comes into play. I'm trying to put to you that there's so many things involved. How do you handle that? For us in Carsales, our journey to Metaflow is actually our journey to automation. Our team started maybe more than 5 years ago, 6 or 7 years ago. That's the birth of our team. Our team is made of software engineers to begin with. And we started with a manual process. So imagine 7 years ago, pre-COVID, where you have to come to office. I'm not sure whether some of you remember that. Engineers have their own physical machine sitting there, ready to go. They can do whatever they want with it to train stuff. And why is it manual, I would say? We use USB to copy data. We have other teams sitting somewhere else like, okay, I need a data. You walk across, USB, come back. Sorry, copy the wrong one. I'm gonna go back, level 2, level 3, come back down. Okay, this is the correct one. Do you name it correctly? No, go back up. So you can imagine, some people think this is fun, but first 2 times, okay. Then you get the angry face. And then once you finish everything, there needs to be a part whereby, okay, we need to get this ready so that the customer can use it, business can see it. How? Oh, it's in the machine. How do we do it? So there are all this kind of manual process involved during that time, context-wise, during the time 7 years ago. And of course, we are not happy when it comes to, okay, we're done. Let's repeat it on a different version. You can imagine, okay, I need a bigger machine. I need more memory. How? I need to talk to so-and-so, need to buy RAM, need to buy GPU, and then you have to wait 1 week. And it doesn't really help, especially if you're the person who is like, I'm in the verge of, my second iteration will solve the problem, but I have to wait 1 week. So it causes a momentum loss of people who are inspired, have a moment of like needing to solve the problem, but they can't because this limitation. We went around searching. Remember, this is the year 2017, 2018. We were starting to look around for tools. ML operations maturity just started, I believe. And SageMaker came into scene. Kubeflow, some of you may have heard of it, came into scene also. And then we were juggling between both. AWS SageMaker, they approach us and say, oh, this is something you can use. And then when we look at it, it didn't have the version control that we want. So that sort of rule out. Again, preface, this is 2017, 2018. Times have changed now, but during that time, it's none. So we ended up with Kubeflow because Kubeflow have flexible infrastructure. Basically, you use AWS, it's Kubernetes cluster. You pretty much, they no longer need to deal with, oh, I need more RAM. Sure. Change a bit of configuration, boom. How much you need? Change it for you. Done. You can have as much as you want as long as you have the money to pay. Then we have version control. Hugo talks about the importance of version control. Previously, our version control is probably labeling, making sure you got the right data or name it correctly. So we have proper versioning using Kubeflow. They call it Kubeflow pipelines. And then we are able to repeat the process of, okay, I need to do this using a different variable again. Okay, I can spin this up again using the pipeline, repeat it, try in a different way. So this helps us tremendously moving from manual process to a better process. That was 2018, and then we were quite happy until there are frictions happening. So 2019 to year 2020-ish, after using Kubeflow for some time, it delivers the product, but they were unspoken pain until it was spoken. And I'm the operations person, so I have a conversation with them. And then we discovered that, hey, during that time, Kubernetes is not something a lot of people like to play with unless you are infrastructure or operations. You asking people who are not specifically natural in that role, data scientists, or they are not supposed to do that. They are not in that world. To like, okay, I need you to build a Docker, and then I need you to write YAML. Then I need you to look into it and use the command line, put it in there, and then change this value, and then you're good. They will look at you and it's like, can you show me? So there's a lot of interaction, and then I became like the go-to person to do things. And you can tell that they can do some parts, but then I need to be involved quite a lot in the chain when something doesn't really gel well when it comes to Kubernetes. I'm not saying Kubernetes is bad. just tell you, Kubernetes is powerful, but you need skill sets to use it. And our team are not made out of that. So we went venturing around, and thankfully, Netflix, open source, something called Metaflow does. I think we discovered it around year 2020, 21-ish. And Metaflow has all this. Was mentioned earlier. It was so good. The biggest difference was that decorator that was talking about, oh, you need CPU and RAM. No longer you need to talk to me or write a YAML. You just put in a decorator and say, Kubernetes CPU is X, memory is X. And that is a native Python interactive language, something that the developers are very familiar with. And that is a big plus. They no longer need to talk to me. They talk to the machine. And compile, that's it. They are happy, I'm happy. That's pretty good, right? So that's something important I discovered, that in order for them to in order for users to, iterate, get things running, and their, creative users flow, speaking natively is important. Not only that, we discovered Metaflow actually has a S3 client that builds into it, and it allows us to access data in a much faster way. And we deal with a lot of images. Cyclops, just now we were talking about 1 million images to deal with, and they are raw data. So this helps us a lot. Not only that, debugging wasn't the happiest moment when we were using other tools, because debugging, you have to check the logs here. Sam, so they approached me, Sam, I can't find the logs. Maybe you have to delve into the machine, the Kubernetes machine, the pod, and grab me something. So with Metaflow, not sure Hugo talked about it, there's this artifact behind the scene that you can access it. It's a self dot, that's the thing that you reference to. And the good thing is you can resume where you failed. Imagine you trained for 6 hours, you waited. Yes, the answer is going to come. No, wrong. Are you going to wait 6 hours again to figure out what's wrong? So Metaflow has this thing called you can resume from where you stop. You can figure out where you want. So it helps us to reduce whatever amount of time that it takes you to train something and continue on from the steps itself. And finally, low to zero dependency on operations engineer. I'm happy. I'm happy. I think it's important to recognize we have that relationship. It's not that they don't like me or I don't like him, but whenever it comes to creating something, if it helps to reduce dependency and allows them to create what they need, debug without a lot of permissions, hoops to jump, that helps. Using Metaflow, I was just asking my colleague, like, hey, tell me, how is it? From what we were before till now, environment setup to having your experiment to create results. It used to be a few days. Then it went down to 1 day. With Metaflow, we pretty much shortened it to almost 1 hour. Once the platform set up, you just went in.
That's great.
Okay, I get my experimental result. So that was a big deal to us.
Everyone's happy, you and me.
Time, you don't need to wait that long. The other one I was highlighting, debugging time. Previously, we had to have different contexts, pulling logs everywhere. With Metaflow, it's very centralized. We were debating how long? 50% reduction. You don't need to figure out, piece all things together. By the time you maybe lost track of the first one. And with that kind of reduction, it helps us save costs in terms of the time spent to do things. So in closing, I'm very happy. When Hugo approached me and said, hey, I want to talk about Metaflow, I said, yeah, of course. Metaflow have helped me. I wanted to say change my life. It did help us. It helps us to be less friction in the team, and it really helps iterate and help us create better products in an efficient way. So back to you, Hugo.
Great. Thanks so much, Sam. So I'm just going to wrap up. I can hear a lot of people wondering, wow, how can I do this myself? I just did want to reiterate Sam's point that one of the most expensive, if not most expensive resource every company you all work for is headcount. It's paying salaries and wages. And yet, so many organizations don't seem to value using tools that improve developer experience and essentially allow their employees to do, 10x. I'm not talking about 10x engineers, I'm talking about 10x tools essentially. Engineers to do as much of their good work as possible. So if you wanted to, as Sam also mentioned, and I mentioned, Metaflow is an open source tool. At Out of Bounds, we provide services that help you get up and running with Metaflow, among other things, but across the whole infrastructural stack. To do this at home, check out our docs at docs.metaflow.org. That's the first place to look. A lot of resources there. Then, if you're interested, check out our sandbox. So we've spent a lot of time, if anyone's used VS Code, you may recognize that as some superpowered VS Code that we've put in the browser. And essentially, to really experience how Metaflow can help you, it requires infrastructural setup, such as access to Kubernetes clusters and schedulers and that type of stuff. So we've set up all that production-grade infrastructure for you in order to play around with in the sandbox. So that's free. Go and check out the sandbox at outofbounds.com. And there are lots of tutorials there, from basic Metaflow tutorials to generative AI models, so audio processing with Whisper, through to NLP, computer vision, recommender systems, these types of things. And we have an active, vibrant Slack community. So if you're interested in these types of conversations, please join us on Slack. We've got over 3,000 data scientists and engineers chatting constantly. You can DM me there at Hugo. And if you want these slides, just I'll email them to you. You can pop that QR code or link. We'll send you to a form where you can let me know and I'll send them to you. So once again, I'd just like to thank AI Camp, Hannah, and the rest of the organizers for hosting this. And Out of Bounds, my employer, is sponsoring a happy hour after this. So if you want to come and have a drink and a chat, it'd be great to see you there. So thanks once again, everyone.